All right, we're going to take a look at those last four relationships on there. So in the previous video, we looked at pain relief with medication and calories consumed in weight loss. So now we're going to take a look at hours of sleep and score on a test. All right, I don't think that there's much of a relationship here because I think that probably studying for a test is a better predictor of your grade. But there is some truth to this, right? If you don't get any sleep before the test, that does impact your cognitive ability and ability to reason through questions. And so maybe that grade that was an A is now more like a B+. Okay, so maybe it has a slight impact on your grade, but it certainly doesn't have a tremendous impact. There certainly isn't a linear relationship there. It's not that if I sleep 12 hours, I'm guaranteed to get an A, because otherwise you guys would all sleep for however many hours it took to earn an A. So this relationship is probably going to be scattered. There is some truth that, like, if you're well rested, it does improve your cognitive ability and ability to process exam questions, but not enough that I would say that there's some sort of strong linear relationship here. So probably more on the side of none or scattered, weak relationship here. The next one is shoe size and GPA. So if you thought that sleeping for 12 hours gets you an A on a test and that sounded like a great deal, this is even better. You don't even have to go to college. We'll just measure your foot size, your shoe size, and then we'll tell you what your GPA is and what diploma you can get. So this one, obviously, there's nothing going on here. Number 5, the time for the mile run and age. So we're going to put age on our x-axis, our explanatory axis, and then the time for the mile run will be on our y-axis. So we don't get that shadow through there. Okay, so someone who's maybe in their 80s, 90s, 100, they can probably, hopefully, walk a mile still, but they're not going to have a great time in general. So I would think that probably the older you get, kind of the more time it's going to take. There are always those outliers, like you see a 90-year-old nun or something that runs marathons. And so maybe you'll get a couple outliers here somewhere, but for the most part, I'd say this is probably going to be a higher time for the mile run. Okay, maybe the younger you are, your body moves a little bit better, you're a little more flexible. And so maybe this time is going to decrease, but I don't know that that holds constant for everybody. For example, you could take a whole class of students in a health and phys ed class in college, and you might have some that are on the track team that can run a 4-minute mile, and then you have some that are not as fit, or maybe they just recovered from surgery, or a broken foot, or something like that. And so it takes them quite a bit longer. And so you have quite a bit of variation, even among people in their 20s. I mean, in general, I would think it's probably, there's a little bit of downhill, but this is going to be pretty scattered. The other thing to consider is these children under the age of 5. So if they're even able to do that mile run, I think you're going to have some of these higher numbers here. Maybe my nephew might be able to do this in like 20 minutes. He runs so fast, he's so exhausted. Hey, but in general, they're hard. Little children are hard to herd in the right direction around the track and other issues. So this is probably going to have some sort of curve, but really pretty scattered and pretty weak. A little bit of truth to it, but not much. All right, and then this last one we have here. So age of car and cost of repairs. So in general, I mean, I would hope if I buy a brand new car that I'm not paying anything for repairs for the first while. And then, maybe as the car gets 15, 20 years old, or I've driven across country several times, that should pick up. What's interesting, though, is while this might be kind of our guess or our hope, there's actually a different curve that fits this better. So let me switch over to the PowerPoint. We'll take a look at that. All right, so here is that other curve. This is called a bathtub curve. And they're showing a high amount for repairs at the beginning. then it levels out for a while. And then what we expected as it gets much older, that 15, 20 years, lots of miles, that you're going to start to see more repairs. So what's going on at the beginning here? At the beginning, this is why a lot of states have what's called a lemon law. You buy a brand new car. My friend did this. She bought a brand new truck, drove it off the lot. She had it for maybe 5 days, and she walked out and the coolant had leaked all over the ground. And she took it back, and there was just more and more and more things wrong with it, despite her buying it brand new. So states have lemon laws because that is a known thing, that sometimes they just come off the production line and they don't work right. That happened with Apollo 13. They had that sensor switch that, had been installed months before the astronaut team had even been selected and the mission had been planned. And yet when they got up there, they went to stir the oxygen tanks, that part exploded, and they were very fortunate to come back alive. So there are those issues. Airplanes especially are known to have that. They, with brand new planes, try to leave extra time because in between flights, it shakes around, things rattle loose. And so there's a learning curve to each new vehicle. And so we get more of a bathtub shaped curve in general with vehicle repairs.